this lesson, we're going to be talking about graphing rational functions. So number one, how is the quotient g of x equals 4x divided by x minus 3 related to the reciprocal function f of x equals 1 over x, and then we're going to sketch the graph in our calculator. So 1 over x is our parent function for a rational function. So anytime we change or manipulate, it will stretch, shrink, translate left, right, up, down. All right. In order to compare apples to apples, though, instead of having a variable in the top, we need to get that to be just a number. So in order to do that, we are going to take that 4x and actually divide it by the x minus 3. So we have 4x, and we're dividing that by x minus 3. Now, I don't have a constant after my 4x, so I'm just going to add a 0 here, kind of as a placeholder. So I'm going to take the 4x and divide it by x. That gives me 4, and then I'm going to multiply. 4 times x is 4x, and 4 times negative 3 is negative 12. Then we're going to subtract, which means this 4x becomes negative, this 12 becomes positive. I add down, and I have a remainder of 12. So I would normally write this as 4 and then plus and then my remainder over x minus 3. But as a personal preference, and again, this is just my personal preference, when I'm looking at rational functions, I like for the fraction part to be in the front. So I'm going to put the 12 over x minus 3 in front, and I'm going to put the plus 4 at the back. All right. Now, we're going to graph both of these in our calculator and compare them. So I already have the parent function in my y1, and I have my other equation in the y2. All right. And I'm going to go ahead and go in my table here. So if you look at the blue function, that's my parent function. All right. I can see that I have a vertical asymptote at 0. I can confirm that as well in my table because when x is 0, there is no y value that goes along with that. I have an asymptote there, and that's because the parent function is 1 over x. I can't divide by 0, so x cannot be 0. All right, I also have a horizontal asymptote when y is equal to 0 as well. Okay, the red function is my other equation after I've manipulated my parent function. Now, it's kind of hard to tell, but we do see that it's shifted to the right. All right, it's definitely more to the right than the blue one was. If I go in my table and kind of arrow over, I can see that it's actually shifted 3 because now my asymptote is when x is 3. All right. Now, if you take a look at your equation, you can see that the reason x can't be 3 is because that would give you a 0 in your denominator. 3 minus 3 is 0, and that's a problem. So from that information, we know that we can get our vertical asymptote from the denominator. That's going to tell us what x cannot be. So x cannot be 3. That also means that this shifted from 0 to 3, so we went 3 units to the right. Now, if you'll remember from all of the lessons that we have done over transformations and translations, anytime you adjust just the x value, that's a left or right motion. So if I subtract 3, that's actually going to move me right 3. If I were to add 3 to that x, it would move me left 3. Okay? Now, also, if you remember from translations and transformations, if you add or subtract a number to the entire thing, that moves it up or down. So I know that I went 4 up. Now, if I look at my graphs, I can tell that if I was at 0, 1, 2, 3, 4 up would be about here, and I do have a horizontal asymptote there as well. Okay, the only other thing left to think about is if you notice these curves right here on your graph of the 1 over x, they're really close together. They're not very far apart here, but these are way farther apart. All right, they're also stretched up a little bit more, whereas these are a little bit more flat. So I know that I have a vertical stretch by a factor of, and the only thing we haven't discussed is that 12 on top, so this would be by a factor of 12. All right, so now we're going to use that long division to rewrite each of these rational functions. We're going to find the asymptotes, and then it says sketch the graph, but I don't think that we need to sketch the graph. You can if you want to confirm what you come up with, but it's not necessary. All right, so we are dividing the 6x by 2x plus 1. And again, I'm going to put that placeholder of 0 out there. So I take the 6x, I divide it by 2x, that gives me 3. Then I'd multiply. 3 times 2x is 6x, 3 times 1 is 3, and then I subtract, so 6x becomes negative, 3 becomes negative, and I have a remainder of negative 3. Now, just like on number 1, I like for my remainder part on these to be in the front, so I'm going to do my remainder over what I divided by, and then put that plus 3 behind it. So we already discussed that we get the vertical asymptote from the denominator. We get the horizontal asymptote from that number that's being added or subtracted on the outside. So for my vertical asymptote, I'm going to take that denominator, the 2x plus 1, and set it equal to 0 and solve. So I subtract 1, divide by 2. So I have a vertical asymptote at x equals negative 1/2. Now, these asymptotes are lines, okay? They're like guidelines on a graph. So you need to write them as the equation of a line. So a vertical asymptote is always x equals and then your number, and a horizontal asymptote is always y equals and then your number. All right, so there's my vertical asymptote at x equals negative 1/2. And then my horizontal asymptote is always at 0, but then I shifted up 3, so that would be at y equals 3. All right, on number 3, we are dividing x by x minus 6. And again, I'm going to add 0 as a placeholder. X divided by x is 1. So 1 times x is x, and 1 times negative 6 is negative 6. And then we subtract. So x becomes negative, 6 becomes positive, and I have a remainder of 6. So I have 6 over x minus 6, and then plus 1. So for my vertical asymptote, I would set that x minus 6 equal to 0, which gives me x equals 6. And my horizontal asymptote, I'm paying attention to that number on the outside, so y equals 1. Now, again, I can only get that information directly in this manner if I do the division and get that number up on top, my remainder part, okay, without the variable. The ratio or the division of two integers. A rational expression is an expression that can be expressed as the ratio of two polynomials, such as p of x over q of x. So we just have one polynomial divided by another polynomial. A rational function is any function defined by a rational expression, such as r of x equals p of x over q of x. The domain of r of x is all the values of x for which q of x does not equal 0. That's because q of x is what we're using to represent the denominator. We can't have a 0 there, so we would have to state that in our domain. So we're going to find the vertical asymptotes. Now notice these are not written with that constant on top. We're not going to divide these out. We're just going to look at them and come up with what we want. So the vertical asymptotes are going to come from the denominator. If I can factor my numerator, though, I should do that. I can't factor 3x minus 2, so I'm going to leave that alone. But I can factor this polynomial on the bottom. So I have a plus and back, which means I'm going to look up front, and I have 2 plus signs. And then what multiplies to make 12 that adds to make 7 would be 4 and 3. So since I don't have a matching factor from top to bottom that would cancel out, I'm going to take those factors on the bottom and set them equal to 0, which gives me negative 4. So we have a vertical asymptote at x equals negative 4, and then another at x equals negative 3. So in this case, we have 2 vertical asymptotes. All right, same thing on 5. I cannot factor 5x, but I can factor the bottom part. So since I have a minus in the back, I have 1 positive, 1 negative. And what multiplies to make 6 that will subtract to make 1 is 3 and 2, and I need that to be a negative 1 in the middle. So 3 has to be negative, 2 has to be positive. Again, I don't have a factor in top that will cancel with a factor on bottom. So both of those factors in the denominator are going to get set equal to 0. And then I'll solve. so I subtract 2. So I have one vertical asymptote at x equals -2 and another vertical asymptote at x equals 3. Now let's talk about our horizontal asymptotes. So we have 3 cases. When the degree of the numerator is less than the degree of the denominator, there exists a horizontal asymptote at y equals 0. So if we are bottom heavy in the degree area, it's y equals 0. If the degree of the numerator is greater than the degree of the denominator, then you don't have a horizontal asymptote at all. So if we are top heavy in the degree area, we don't have one. When the degrees are equal, top and bottom, then we're just going to take and divide the leading coefficients. So when you're looking at horizontal asymptotes, we're comparing degrees. So the degree on top is 1, and remember that's just the highest power of your variable. The degree on bottom is 2. So when the degree on top is smaller than the degree on bottom, it's automatically a horizontal asymptote at y equals 0. So number 7, degree on top is 1, degree on bottom is 2. So again, top degree is smaller than bottom, so y equals 0. Number 8, the degree on top is 2, the degree on bottom is 1. So when the degree on top is bigger than the degree on bottom, there is not a horizontal asymptote. We don't have one of those on this one. All right, and then we have degree of 2 on top, degree of 2 on bottom. When the degrees are the same, you're going to take and divide those leading coefficients. So I'm going to divide 2 by 1. 2 divided by 1 is 2. So I have a horizontal asymptote at y equals 2. All right, now we're going to practice some graphing. So if I can factor the numerator and the denominator, then I should do that. I can't factor either of these. So I'm going to go ahead and start with my vertical asymptote. So my vertical asymptote comes from the denominator. I'm going to take that 3x minus 4, set it equal to 0. So I add the 4. That gives me 3x equals 4. I divide by 3. So x equals 4/3. Now, since you are graphing these, if you prefer to have a decimal, you can write that out to the side. 4/3 as a decimal is 1.3. All right, and that's my vertical asymptote. My horizontal asymptote is going to come from looking at those degrees. So the degree on top is 1, the degree on bottom is 1. So I'm going to take the 2 and divide it by 3, so y equals 2/3. Again, if you want the decimal for that, that's 0.7. And then something that we haven't talked about yet is how you can get one other piece of information from this. All right, I can get my x-intercepts. So an x-intercept, every x-intercept has a y value of 0. So if I were to take out y and put a 0 in its place, I'd be saying, what would make this fraction equal to 0? So if I had a fraction, what would make that fraction equal to 0? That would be when there's a 0 on top, because if there's a 0 in the numerator, the whole fraction is 0. So if I want this fraction to be 0, I just focus on the top and say, okay, well, what would make the top 0? So to get your x-intercepts, in this case, you just have one factor, so you're going to have one x-intercept. You take that top, and you're going to set it equal to 0. So I subtract 1. Divide by 2. So I have an x-intercept at -1/2. So before we get a table of values, we're going to go ahead and plot this stuff on our graph. So I have a vertical asymptote at 4/3, which is 1.3. All right. So that's about right here, roughly. Okay, it's not going to be perfect, but it should be close. So there's my vertical asymptote, and then I have a horizontal asymptote at 0.67. So that's a little over halfway. All right, the other piece of information I got was my x-intercept, which is at a -1/2. So I can put a dot there for my -1/2. Now I'm going to have to fill in with other points. So we're going to use our calculator to help us with this. So clear out anything that you have in there. Now I will say, if you choose to use the box over the box, your table is going to fill in with fractions. If you would rather have decimals, then you're going to have to not use the box over the box, and you're just going to put parentheses around your top, use the division slash, and then parentheses around your bottom. All right, then when you go to that table, it's going to have all of those as decimals. So you can see right here, it looks like we do have a vertical asymptote at the 1.3, and it looks like we do have that horizontal asymptote at the 0.7. So we just need some points to fill in. All right, so I'm just going to pick points that are a little easier for me to graph. I'm going to fit as many as I can. Now, I already know that my horizontal asymptote is at 0.7. So I'm going to try to get as close to that as possible. So I want my y values to be close to the 0.7. Now on the left side, I am underneath that asymptote, and on the right side, I'm above it. So on this left side, this is about as close as probably you want to be, is this negative 6.5. So I'm going to put that in my table here in just a second. And then we need just some other points. So I'm going to graph the negative 2.3, the 0, negative 0.25, and the 1, negative 3. That's going to give me this over here. But once we get to 2, we've passed over that vertical asymptote that we have. So we have 3 and 1.4, and then 5, 1. But again, remember, you're getting close to this asymptote, so that's pretty close. 1 is pretty close to being above your 0.7. All right, 0.7 is really close to 1. So you're pretty close on the above side. All right, so we're going to fill in our table with those values. So we had negative 6.5, negative 2.3, 0, negative 0.25, 1, negative 3, 2, 2.5, and 5, 1. All right, and we're going to graph those points. So we have negative 6.5, negative 2.3. Oh, I went too far over. Zero, negative 0.25, 1, negative 3, 2, 2.5, and 5, 1. All right, and when I graph these, I am just going to start at one of my points, and I'm going to draw in and stop at the other and put arrows on the ends. Remember, you're not going to touch or cross those asymptotes. All right, and then you'll do the same thing here and put arrows on the ends, and then you have your graph. So number 11, again, we're going to start by factoring if we can. We can't factor either of those. So I'm going to start with my vertical asymptote. All right, my vertical asymptote comes from the bottom, so I set the x plus 8 equal to 0 and solve. So I have a vertical asymptote at x equals negative 8. And then I have a horizontal asymptote. I'm going to compare those degrees. Degree on top is 1. Degree on bottom is also 1. 4 divided by 1 is 4. And then I can get my x-intercept by setting that top equal to 0. So 4x minus 3 equals 0. I'm going to add 3. So 4x equals 3. Divide by 4. So I have an x-intercept at 3/4, which is the same thing as 0.75. So we're going to go ahead and graph these. So 0.75, I have an x-intercept. And then I have a vertical asymptote at -8. 8. So it looks like part of our graph on this one isn't going to get graphed by hand, but we will look at it in the calculator. And then I have a horizontal asymptote at y equals 4. So let's graph this and take a look at it. So we have 4x minus 3 divided by x plus 8. Now, if I zoom out, I'm going to zoom out on this so we can kind of get a better look. You can see there are two parts to this graph, but this part over here is kind of off of the graph where we're trying to plot. And so the only part we're really going to be able to graph is this part right here. So I'm just going to pick points as far as I can fit onto this graph. All right. So I just took points from my table. All right. So we have -5, -7.7, -3, -3, -1, -1, 2.56, 1.5, and 9, 1.9. So those are all numbers I got from the table. So we have -5, -7.7, -3, -3, -1, -1, 2 up a half, 6 up 1.5, and 9 up 1.9. So we don't have a super good picture of this, but we can still draw what we can fit on our graph. All right, number 12. I can factor the top. It's the difference of two squares. So I end up with x plus 2 and x minus 2. I can't factor the bottom, but here's where something different happens to us. So if you notice, you have an x plus 2 on top and an x plus 2 on bottom. That's going to cancel and just leave you with x minus 2. When you have something cancel, it's going to create a hole in your graph. So I have a hole at this x plus 2. So I'm going to set that equal to 0 and solve. It's kind of like a vertical asymptote, but since it's canceling out, you have to account for it. So I'm going to have a hole when x is -2. Now, since I don't have a denominator left, I don't have a vertical asymptote. And the degree on the top is bigger than the degree on the bottom, so I don't have a horizontal asymptote. And all I'm left with is this linear equation, so you don't really need a table of values. So I have a y-intercept of -2 and a slope of 1/1. So I'm going to start at -2 and go up 1, right 1, up 1, right 1. Or I could go down 1, left 1, down 1, left 1. And I'm just going to kind of draw that in. Hopefully you guys can draw a better line than I can. All right, and then I need to put my hole in there. I have a hole when x is -2. So I'm going to go to where x is -2. I'm going to drop down. I'm going to erase right there. And I'm going to put a hole on my graph when x is -2. So I just go to where x is -2, drop down right there, put a hole on my graph. And then I'm done. All right, on this last one, we can factor the top. So let's do that. It may be helpful. We have the difference of two squares. So we have 2x plus 3 and 2x minus 3. We can factor the bottom. We have a plus and a minus. And then we have what multiplies to make 15 that will subtract to make 2. and that would be 5 and 3, but I need it to be positive 2, so 5 has to be positive, and 3 has to be negative. All right, I don't have any matching factors from top to bottom, so I'm going to go ahead and start off with my vertical asymptotes. I have 2 of them because I have 2 factors in the bottom. So I have x plus 5 equals 0 and x minus 3 equals 0. So that gives me negative 5 and positive 3. For my horizontal asymptotes, I'm going to compare degrees. I have a degree of 2 on top and a degree of 2 on bottom. So I'm going to take the 4 and divide it by 1. So I get y equals 4. And then I do have 2 x-intercepts because I have 2 factors on top. So I set the 2x plus 3 equal to 0 and the 2x minus 3 equal to 0. So I subtract 3, divide by 2. So I have 1 x-intercept at negative 3 halves. So I have 2x equals 3, divide by 2. So I have another x-intercept at 3 halves. So we have several things to plot here. So we have 2 vertical asymptotes, one at negative 5 and one at 3. So let's go ahead and plot those. I also have a horizontal asymptote at 4. And I have 2 x-intercepts, one at positive 3 halves and one at negative 3 halves. So that would be negative 1.5 and positive 1.5. All right, now I need to go to my calculator, plug this in, and get some points where I can plot these. So we have 4x squared minus 9 divided by x squared plus 2x minus 15. Now, because I have 2 asymptotes, I have 3 sections. I have the left, the middle, and I have the right. So I'm going to pick values in all 3 of these sections from this table over here. I have already done this. So what I chose to graph, I just need enough that I can actually get the curve. So negative 7, 9.35, negative 4, negative 7.9, negative 3, negative 2.25, 0.6, 2, negative 1, 4, 6.1, and 8, 3.8. So we're going to plot these points. So we have negative 7, and then all the way up to 9.35. Then we have negative 4, negative 7.9, negative 3, negative 2.25, 0.6, 2, negative 1, 4, 6.1, and 8, 3.8. All right. Now, if you will notice, I have a horizontal asymptote at y equals 4. All right. But my graph is going to end up crossing over it. That is okay. You can cross a horizontal asymptote. You cannot cross a vertical asymptote. Now, I did notice that I only had 1 point in this left section. So So I'm going to go to my table and kind of arrow up. I think I chose that. So let's just go with negative 9, 6.6 and add that one in. So negative 9 and then 6.6. That way we have at least, a couple of points in each one. So I'm going to draw this in. We need to draw the middle. And then we'll draw this side as well. And that is how you graph rational functions.